Je parle un peu français, mais comme Philippe a dit, je vais parler en anglais. So, yes, my name's Liz Rice. If I speak too quickly, please just start raising your hands so I know. I will try to kind of keep myself under control. So at Aqua Security, we have a product that helps companies secure their containerized deployments. And something we hear quite frequently is that as people are embarking on a journey to containers, they're embarking on a journey to cloud native, to orchestration, they have concerns about security. So this morning I'm going to talk a bit about why they're concerned, what it is that worries them about moving to containers. And we'll also talk a bit about how containers, microservices, orchestration, and automation can really, really help with security. So can I just have a show of hands? How many of you are already using containers? A fair few. And how many of you are not using them yet but thinking about it? Okay. And everybody who raised their hands, how many of you worried about security in that process? Yes. Okay. So let's just start by reviewing a traditional deployment. This is really, really simplified. But we would typically have developers who write code. They produce some software artifacts. And we would traditionally have a separate operations team. They provision the servers, and they deploy the software artifacts onto those servers. We'd typically have a separate security team, and they would look after things like networks, firewalls, maybe installing traditional security tools like intrusion detection. And they would also have a regular patching process where they would find out about vulnerabilities in the software that's running on those servers, and they would patch those servers to prevent them from being vulnerable. The kind of attacks that they are worried about would be the bad people exploiting known vulnerabilities. There are thousands and thousands of known vulnerabilities in third-party libraries. Who's heard of things like shell shock? Anybody? A few hands. So there are thousands of these vulnerabilities. Some of them are well known. Some of them don't have names, don't have code names like shell shock. But these vulnerabilities are flaws in software that allow an attacker to somehow get into your deployment and do bad things. Shell shock is an example where an attacker can execute code remotely. The idea is that you patch these vulnerabilities, you're no longer vulnerable, and the attacker can't exploit them. We also see network penetration attacks. People, if you ever stand up a website, within a matter of minutes or hours, you will see attacks, people just probing your network, checking to see what ports are open, looking to see if there is a weakness. And then finally, there are the 0 days. These are vulnerabilities, flaws in software that haven't yet been sort of described officially. There isn't a known patch yet. You can't do anything to address a 0 day because there is no patch. All you can do is try to either alert or use other security tools to address these 0 days. So all these attacks happen irrespective whether you're using traditional deployments or microservices. Why would orchestration change these attacks? Well, of course, it doesn't change these attacks. But there are some differences in how we can think about defending ourselves from these attacks. In a traditional monolithic deployment, we have people, humans, typically manually deploying software and putting it on servers. So they know where that software is. If we move to containers, to microservices, we will have typically an orchestrator. It's automatically putting those containers somewhere in our servers, and we don't really know where the orchestrator is going to put each software artifact. And there are typically going to be hundreds of microservices. We don't just have one software artifact anymore. We're using agile methodologies. We're breaking things into microservices. There could be hundreds of different microservices. And each microservice could have many instances, leading to thousands of containers. And the point of a container is that it's self-contained. It has all its dependencies in it. So every one of these containers could have vulnerabilities in it. Plus, because we're probably working in an agile way, we've automated everything. Research from last year from a company called Datadog measured that the average lifetime of a container in production is just 2.5 days. Traditional software is deployed for months at a time. These last for just a few days. So it's almost impossible to imagine trying to patch those containers. This is really the reason why people worry about security when it comes to containers, because there are so many instances and they last for such a short period of time. You can't possibly manually keep track of them all. And a vast majority agree, as did many of you, that security is a concern when moving to agile, DevSecOps, containers, and orchestration. The key to solving this problem is automation. Just as automation helps you with the dev and the ops part, it also helps you with the sec part. So let's look at how vulnerability patching works traditionally. The security team would get an advisory from a vendor that says, this package, or they would look up to find out which packages have vulnerabilities. And sometimes those vulnerabilities are really easy to exploit, so they have to be patched pretty quickly. So the security team, typically, traditionally, this has been on a monthly basis, manually go around and patch all those vulnerabilities on each server. How can you possibly be expected to manually apply patches to all those thousands of containers? That's an insanely big task. And the answer is, of course, you just don't. We do not patch containers. And in fact, it's considered an anti-pattern, a bad thing, to change the software in a running container. Instead, what we do, containers are instantiated from container images. And we scan those images, we use a scanning tool to check every container image for vulnerabilities. If we find images with vulnerabilities, those need to be patched. The images need to be patched. And then we can automatically replace all the running containers with instances from those patched container images. And this is all automated. We have to be doing a lot of this as part of our pipelines, as part of our CI/CD. As our code moves through the pipeline, as we build code, we're building these container images, and we need to be scanning those images to find any vulnerabilities. And if we do find vulnerabilities, that shouldn't pass the build. It should be just like failing a functional test. We just shouldn't allow that artifact to pass through the pipeline. We can also have what's called admission control. This is something that security tools can do. Kubernetes has admission controllers as well as part of its kind of layout. And admission control can check that the software we deploy meets our criteria. And that criteria might include, don't deploy anything that's got a high severity vulnerability, because that is asking for attackers to, gives them an open front door. So it all is automated, and if we fail a build, we're alerting the developer. The developer can fix the problem as just in the same way that they would fix a functional problem. So what about those security measures that we had in the traditional deployment? We had firewalls and network configuration. Actually, this is fine. We might still want to keep this. If you have a VPC in your traditional deployment, there is no reason to change that for your container deployment. If you have a web application firewall, if the APIs stay the same, the firewall can stay the same. It's still offering you exactly the same protection as in a traditional deployment. Then there's also the intrusion detection tools. Now, intrusion detection is there to say, has an attacker got into your deployment somehow? They got into your servers. And it basically works by looking for changes to the file systems. The problem with traditional intrusion detection is that it doesn't know to look inside those containers. And this is one place where you really, if you're going to move to orchestration and containers, you do need to update your tooling, because traditional tooling just doesn't know how to cope with intrusion detection in containers. There are also some things that actually improve security, or at least give us the opportunity to improve security as we move to containers and microservices and orchestration. The first is container firewalls. So in just the same way that moving to microservices breaks our architecture, it decomposes it into smaller, manageable pieces, we can see what traffic is supposed to flow between those different microservices. And it's relatively easy to build a model and say, well, this container is supposed to speak to this other container. This container shouldn't ever be communicating externally. And we can use that to build up what we might call network nano-segmentation, really decomposing our firewall in the same way that we decompose the architecture of the product. As an example, suppose you have an e-commerce site. Is anybody here running an e-commerce platform? I can see a few hands, a couple of hands. So in e-commerce, in microservices, it's very common to have a separate microservice that does product search. You type in, I'm looking for this thing, and there'll be a microservice that actually queries the product database to find what products match your query. Totally makes sense for the product search microservice to talk to the microservice that owns the database. It does not make any sense for product search to be trying to talk to any payment-related containers. If you start seeing traffic between a product search microservice and a payment microservice, that is probably a sign that something bad is happening. And you want to protect that. You want to prevent it from happening. And you can do that with container firewalls. So it's actually a stronger, more granular security than you would have if you just have a firewall all around the outside. In a similar way, we can decompose runtime. We can look at what is supposed to be happening on your servers, and we can break that down by service, container by container. Runtime protection has traditionally been done on Linux with Linux kernel security tools like SE Linux on Red Hat, or Set profiles, AppArmor profiles as well. And these are all profiles that allow you to limit the system calls and the file access that particular applications can perform. The trouble with these traditional Linux security module approaches is that they're very effective, but they're very hard to manage. It's very hard to build up the profiles effectively. You can use these in containers, though. And in fact, if you're using Docker, Docker by default has a very, very effective seccomp profile that is really applicable for kind of 99.9% of applications, of containers, but does add a significant level of protection. Over and above that, something we can do in a container world is look at the individual applications, the individual executables that are allowed to run in each individual microservice. If we contrast with a traditional deployment, if you go to a server in a traditional deployment, it could be running dozens of different executables. And you may have executables that run from time to time because your security team is SSHing in to apply patches. In a containerized world, we can be much, much, much stricter about what executables are allowed to run inside every container. Let me give you a specific example, and I'm going to use shell shock and Apache. So shell shock was a vulnerability in Bash that was discovered, I think, in 2014, and it was incredibly easy to exploit. So if you're running an Apache web server, by and large, all it needs to run is an Apache control executable and some number of, they're called HTTP daemons. In Apache, if you want to create some dynamic web content, you do this using what's called CGI scripts. And these are also executables that you would expect to see running. So if we get a website request for one of these dynamic pages, in my example, it's hello.cgi, that gets handled by one of these HTTP daemons, and it executes that hello.cgi script. And that's all fine. That's good. It's behaving as expected. Now, suppose you have that shell shock vulnerability. An attacker could craft a web header to ask it to ask the server to execute basically any executable that it wants to. I imagine that all of you here, if you have got Apache web servers, they're all patched and not vulnerable to this anymore. But I guarantee there are thousands of websites out there who are still vulnerable to this. And any attacker who types in a particularly crafted header to the web request can execute code of their choosing. Now, if we have runtime protection, container runtime protection, where we say you're only allowed to run Apache control and HTTP daemons and some CGI scripts, but if you try to run anything else, that looks suspicious. So it's going to run our hello CGI script as expected, and that's fine. It matches the profile. We expect that, and we allow it. But if we see the exploit, somebody's trying to exploit that and run, in my example, something called do something, that is trying to start a new executable. And with runtime protection tooling, we can spot that. That executable is not expected. It's not something we have included in the profile for this container. And it's reasonable to do this. It's reasonable to say a container should only do a certain set of things because it has a single purpose. If it's a microservice, it doesn't do general purpose processing, and it's only expected to run a certain set of executables. So this can be hugely powerful. It means that if you're using container security tooling that includes runtime protection, even if you have an exploit, even if you have vulnerable code in your container, at the point where it tries to execute something unexpected, it can't, because it's outside of the expected profile. So in fact, even if it wasn't a known exploit, even if it was some new zero-day, as yet to be discovered exploit, that protection is still in place, and you still can't execute my arbitrary, do something command, because it's outside of the profile. So this is really this ability to decompose not just your software architecture, but also your security problem can be hugely powerful. It gives you much, much greater granularity in security. It all really relies on automation and the addition of this ability to decompose problems into small self-contained pieces. We talked about 3 kinds of attack at the start. The exploitation of known vulnerabilities. Under orchestration, we address that by building scanning into the CI/CD pipeline, by automating our vulnerability scanning. We talked about network penetration. And in addition to firewalling around the whole deployment, we can also break down the networking between our containers using nanosegmentation to really finely control which containers can speak to which other containers and get much, much stronger defenses against lateral movement within a deployment. And because if we're using runtime protection, we can build up a profile of what a container is supposed to do. We can protect against the unexpected, the unknown vulnerabilities. We can protect against those attacks simply by disallowing or alerting on things that are unexpected behavior. And those things allow us stronger security, better defenses than in a traditional deployment. There are several tools out there to help you with this. Aqua is just one of them. So we talk quite a bit about automation, and when we talk about DevOps, we talk about continuous integration and continuous deployment. If you're going to talk about DevSecOps, I think we should also be talking about continuous security. Merci beaucoup.
Philippe, thank you. Thank you, Liz. I'm sure there's questions.
Before question, there is a synthesis. Liz, thank you very much for that introduction to cloud container security. So, 3 points. I would say it in French, but it's better for the audience. L'orchestration des containers, si vous l'avez bien développé, ça va nécessiter de nouvelles approches en matière de définition des mécanismes de sécurité. Ces points de sécurité, les points de contrôle de sécurité peuvent et doivent être conçus dès les phases amont dans les pipelines CI/CD. Et de par leur nature à se concentrer sur des tâches très spécifiques, les containers de microservices sont paradoxalement plus adaptés pour détecter les failles de sécurité. I was right? Et j'ai eu des questions de la part de la salle. Alors, j'ai appris un nouveau mot aussi. Distroless Docker.
Il faut parler lentement pour moi.
Are distroless, you understand that term? Distroless Docker images?
Destroyers.
Destroyless, maybe?
Distroless.
Ah.
Yeah? Yeah, destroyless? Is that what we're...
So the question was, are destroyless Docker images a good answer to security threats?
Okay, yes. So destroyless is a whole new interesting thing, but I think this is distroless. So this is the idea of a container image that includes a small amount of application software. So a lot of the time you have your application plus all its dependencies plus a whole Linux file system. And any exploit in any of those files could potentially be a vulnerability. The idea with distroless is that you limit you put as little code into the image as possible, so there's a much smaller attack surface. There are just fewer executables, fewer files that could possibly be exploited. So yes, minimizing your container image is a huge benefit, yes, and very much best practice.
Second question is more aquacentric. Who are your 3 major customers and your 3 best competitors?
Good question. So our customers, we have, I think, is it 5 out of the top 10 global banks are now customers? So a lot of our customers are typically finance, banks, insurance companies, large media organizations as well. I'm trying to remember who we are allowed to talk about publicly, because there are certainly some that we are not allowed to talk about publicly, a lot, unfortunately. Fred, prompt me who I can say. Sorry? 150. Well, yeah, okay, 150 customers total. And yeah, some of them are very much household names. One of them is one of the very, very large banks in Paris. I should probably stop there.
Did you answer the question regarding competition?
Okay, competition. Yeah, okay. So people often talk about Aqua Security and a company called Twistlock. There are some smaller companies that we see occasionally. I would say Twistlock are really the most serious of our competitors. There are also some, say for example, pieces of the solution. Say for example, the image scanning part. There are open source solutions for that. But they tend to be, they tend to have a less complete view of vulnerabilities, and the consequences are that you're more likely to see false positives. So weirdly, the worse your vulnerability database is, the more likely you are to see false positives, and that's really what differentiates the commercial scanning products from the open source ones.
Next question is, how do CSPs, cloud service providers, compare with regards to containers? I should suggest container security, probably. So how do CSPs compare with regards to container security?
CSP being what? Container security providers. Yeah. So really what the differences are between us and our competitors, I suppose. A lot of the approaches are, there's a lot in common. The differences will be around scale is one thing, your ability to support a very large number of containers running on a very large number of nodes. That's definitely something that we're proud of. Other differences are quite subtle differences in how you handle an attack. So one thing you could do if you see anomalous behavior, if you see bad network traffic or bad executables, one approach would be to kill the container. And we don't do that, and the reason is because if you start killing containers, you can end up effectively giving yourself a denial of service attack on your own deployment, which would be bad. So some of the, there are differences in functionality, but those I would say was approach to scaling and approach to how you handle detecting a problem that are the main differences.
And one last question, which calls for a short answer. Why traditional security tools just don't do the job with containers?
Right, yeah. So traditional security tools are very much designed to look at changes to files across a server. They don't really know how to inspect what's happening inside a container. And the problem is, if you're relying on traditional security, particularly intrusion detection systems, they will say there are no problems. And actually there could be problems happening inside the containers of which they are unaware. So it may look like all this rosy and lovely, but actually you need something to be telling you what's happening inside your containers and your container images.
Thank you, Liz.
Thank you, Liz. Thank you very much.